Hey, what's going on, folks? It's Mike here, and welcome back to the Deprogramming Language series. In today's lesson, I want to introduce a really exciting concept, the idea of compile time programming. And this, in fact, is one of D's superpowers. So with that said, let's just go ahead and dive to the Deprogramming Language website and start to learn a little bit more about this. Now, when I first tell people or introduce them to the Deprogramming Language, this is one of the things that I like to do. I like to go to the front page here, like we've always done, click on an example here, and I'm going to go ahead and click on this sort an array at compile time. Now, you can kind of see here, but usually what I do is I hide the top here, so you have no idea what this code's going to do. And then I go ahead and run it here. And we can see that this program ran and sorted the range here. Now let's go ahead and just reset this so we can see what's going on here. But what's really interesting that you might not have caught here is that, well, we're doing our void main. We have our local import, which is going to be important for some of the compile time programming stuff that we do later. That's nice that we can actually put this nested within a function. There's a reason for that. And then we can actually call our function using the universal function call syntax we've talked about. An enum is something that is established at compile time, so we know what's in this array. And we can actually sort this data at compile time because, well, we have the data here. It's being initialized at compile time. So again, when we've talked about enums, this is one of the reasons here. It's a static fixed size array here effectively. And because we have all the knowledge that we need, we could just run a regular good old sort function, and D will use something known as, or what we call, the compile time function execution, or that is just a fancy way of saying we'll try to compile and evaluate code at runtime, and then we can print out the message at compilation here. Okay, so to understand this, that this all happens at compile time here, and then we print at runtime, the only work that we're doing when we're actually executing our program is printing out starting program. But meanwhile, anything that could have been evaluated at compile time has been done. Okay, so this is a little bit of a weird idea, so let's just go ahead to the whiteboard for a moment and try to understand this. So usually when we run a program, or rather I should say when we write software, we think about we write the software, we save, then we compile, and then we execute, and then we repeat this, right? That's sort of the cycle of a compiled programming language, right? We write our code in some source file, we save it, compile it using the D compiler, and then we execute and look at the results here. But what we found out after a while here, and this is something that, well, this has existed in programming languages for quite some time, but there's really a nice trend these days of modern languages like the deprogramming language to, during this compilation step, say, well, if I can spend some time here, so spend time executing code, and I'm going to specifically put this is developer time. So me, when I'm developing my software here, I can at the runtime, which is here, I can save users time. Okay, and this can be an ideal trade-off, right? If I'm writing software and I'm going to deliver that software to millions and millions of users, and they get an executable or a program that's distributed that's faster because we've already done some of the computation at compile time, then that's great, right? So if I go back to this example here, where I've done the sorting, for instance, ahead of time, that's very nice. Again, we don't have to think about doing that computation while our program's running. We don't have to spend the user's resources doing that computation. There's also nice benefits of, if you've heard of things like undefined behavior, some of those problems go away because at compile time we have to know and be able to get an answer. And you might argue, well, Mike, why don't we not even bother to do this whole, compile time function execution thing? I can just manually sort this array and set that up. Well, that's certainly true here. But there's some really cool things you can do with the deprogramming language. Again, any sort of computation that can be figured out at compile time, such as feeding in these values from some file at compile time. And maybe you want to change that in your build system, for instance, to run different loads of data. And again, that would be really hard, or you'd have to create another sort of pipeline to do that. But instead, we can just use the regular D code that we write anyways to evaluate these things at compile time. So if you've ever heard of some of these other things like meta programming, some of these other ideas that happen at compile time or generate other code at compile time, there's some really, really powerful things that we can do. Thus, the sort of intercession from our topic in the series and why we're talking about compile time here. So I want to go ahead and just do a real simple example here to, again, introduce this idea. So let's go ahead and think about writing a little program here. I'm going to use void main. I'll keep my import local for standard IO here. And what I'm going to go ahead and do here is do a write line, say hello at runtime. And then after, I'm going to come here with pragma. And I have special pragmas where I can write a message here, hello at compile time. Okay, where I can write out a message that happens at compile time. So let's go ahead and run this with RDMD here. And we'll see hello at compile time, hello at compile time, and hello at runtime. Okay, so why do I get this twice here? I'll answer that in a moment. But if I run it again here, well, we'll see here that we didn't have to recompile our program because we didn't make any changes. So you didn't see that message, hello at compile time here, right? Nothing changed. We didn't have to recompile. Now RDMD has to sort of build twice and get itself the cache sort of set up for the build system. But if we just run this with DMD, and let's make a change here, just to make sure that we've made a change at compile time. Let's go ahead and just add some exclamation marks here. I'll do DMD, the main file. We'll output this as program here. We'll get hello at compile time, and then we run our program, hello at runtime. Okay? Because again, we're utilizing this compile time feature with pragma to write out a message at compile time explicitly. So this is how, again, in the little example here, in the D programming language website example here, we have a way to write out our sorted array just as we normally would. Now we're going to find out how to do some more interesting computations here. But let's again just quickly look at this pragma here. We're going to go to the documentation, the language reference, and pragmas here. And we'll see that we have some neat pragmas here for passing special information to our compiler, right? So if you're coming from a C++ world, you've maybe seen pragma once, or pragma, open MP blocks, or these types of things, or maybe something that you learn about. Let's see if we can find message here for some of our pragmas here. And basically this is each assign expression, that's over here, is evaluated at compile time and then are combined into a message, okay? So that is just one of the compile time features here. So again, the rationale is that we need some way to use or have the equivalent of write time at compile time so that we can just print out what's going on here. So we're going to find that this is one of our compile time features, but there's other neat things that we can do at compile time, such as static assert, which I believe we will cover later on in this series, or I should say we certainly will cover it later on. But it opens up a lot of doors to interesting things, like for instance, unit tests, for instance, that you can actually run at compile time. And we haven't even really gotten into some of the cool features of D, for instance, with unit testing and the built-in unit tests and documentation and all those sorts of tools that we have. But we will certainly get to those. So anyways, just wanted to introduce this concept because we're going to talk about something in the next episode known as a mixin, and I want you to have this idea of what's going on at compile time just a little bit ahead of time before we jump into that. Anyways, folks, with that said, we're going to be covering some more cool stuff on compile time and templates and metaprogramming and all these sorts of things coming up. So make sure if you want to follow along, you can check out courses.msha.io on the D language course here, and it's the same lessons that you're seeing here on, if you're watching them on YouTube, for instance, just in a distraction-free environment, and you can track your progress. Anyways, folks, hope you enjoyed that. Hope you're excited about this. And if you haven't used a language previously with a lot of different compile time capabilities, it really is a interesting way to think about programming and testing and how you build software. Again, thinking about that distinguishment between compile time and runtime. So if you're coming from C++, there are certainly more compile time features like with const.expr as a simple example that are coming into the language, but D has a lot of that built in with just sort of the idea of if we can evaluate it at compile time, why not? Why not save that computation? And there's also different ways to check, for instance, if something happens at compile time. So if you use like an underscore CTFE, I believe, you can see if something was. So again, we'll look at some of the different ways to debug your code at compile time and runtime as well. But anyways, it's a super cool thing about the D programming language, and I wanted to share that with you. Anyways, with that said, folks, I'll look forward to talking more about this in future lessons. And as always, thank you again for your time and attention, and we'll see you in that next video.